Now let's talk about the medium or the tissue if we're talking about diagnostic medical sonography or diagnostic ultrasound. The tissue is the material through which the sound propagates. The correct term of the tissue is a medium. The medium can be best understood in the forms of its bulk modulus and acoustic impedance characteristics. First of all, the concept of bulk modulus is quite difficult to explain, but it is the amount of pressure required to compress a small volume of material, a small amount. In other words, how much pressure needs to be applied onto the material in order to change its shape or form. And that would be a bulk modulus. I can give you an example. For example, the desk that you're probably sitting next to when you're watching this video, it's made out of plastic or wood, so it's a solid material. So if you'll try to change its shape with your own hands, most likely you will not be able to do that because you're not applying enough pressure to change its shape unless you break it, right? But if you take a cotton ball and try to change its shape with your fingers, you probably will be able to do that because you will need less pressure to accomplish that. Acoustic impedance is the other concept. Impedance is the resistance to sound propagation, and we're going to discuss impedance later on in this course. But bulk modulus and acoustic impedance are main characteristics, main variables that influence the propagation of the sound through the tissue or sound through the medium. And the quality of the medium, the quality of the tissue, which are density, compressibility, flexibility, are the main factors that influence how the sound propagates through the tissue. Remember the golden rules that we discussed in the previous lecture, that medium is the one which determines the velocity of sound propagation. So we can assume that tissue density, tissue compressibility are the main factors that determine the way sound is carried along with the material. Now, let's take a look at the connection between the density, compressibility, and flexibility of the materials. You see the cube that has a lot of particles in it, which means high density cube. And then the same cube with less particles, less dense cube. The left cube, which is denser, cannot be flexed or cannot change the form, the shape. The right cube, on the other hand, which is less dense, less particles are in it, can change its shape and can be compressed. That's the connection between the compressibility and the density.